It's time to start our conference. This year is a third year of disruption. In 1990, we have COVID-19. The next year, the second quarantine. This year, the war in Ukraine. I understand that the fourth conference must to be at least in not mixed, not blended, only real mode. I hope that our country for this year, not next, not any far times in future, will win. Will win in all fronts before us, as war, as science, and education front. Our front which we fighting now. I would like to invite all of us this next section to fruitful cooperation in all aspects for natural science, technological, computer science, and educational technology. I would like to introduce this session chairs, Tatiana Anatolievna Vakaliuk, Zhytomyr Polytechnic, and Andrei Mykolaievich Striuk, our constant support for years. Tatiana Anatolievna, let's start.
Good morning, dear participants of the conference. We are glad to welcome you to the 14th International Conference on Mathematics, Science and Technology Education. Our conference is devoted to topical issues on mathematics, science and technology education, along with technology learning, including blended learning, electronic learning, ICT-based assessment, mobile learning, and all. Today we have a computer science section and workshop on edge computing. Now Andrei Mykolaievich.
Andrei Mykolaievich is now working for connection some participants. So I think we can start. As Tatiana Anatolievna says, we have some workshops this conference. Unfortunately, this year we can't make this workshop in real. For the second time, the DOORS workshop, edge computing workshop, consists this year from the 7th high quality talks, which will be introduced in the first fast of this session. The next workshop, the STEAM workshop, which must be in the fine Sternopil city. Unfortunately, the talk of these workshops, we try to introduce for tomorrow's section. At our session, the most of participants from Ukraine, but we have a guest from Philippines. So I ask you to make our comfortable work in any language. The main language for your talk is definitely English. The question answer sessions in any language, but in any case, the English is the main language of our conference. Thank you. Andrei Mykolaievich can start.
Now we invite the first author to speak. Yes, it's Maria Volodymyryevna Marienko.
Hello, dear colleagues. The topic of our study is Smart System of Open Science in Teachers' Education. In the condition of globalization, European integration, and acceleration, digital transformation of many spheres of human activity, there is a need to create a competitive educational sphere in Ukraine. Formation of modern human competencies and qualifications, increase the level of accessibility and quality of education. Solving the problems of the introduction of cloud-based system of open science in educational institutions is an essential prerequisite of training specialists capable of appropriate, scientifically sound application of emergent ICT in their future educational and scientific activity. Analysis of recent research, the problem of design and use of the cloud-based services and technologies of open science in educational institutions are among the top in the field of digitalization. To find out which learning platforms are used in Ukrainian institutions of pedagogical education and whether there are adaptive ones, we conducted a survey where representatives of 31 Ukrainian institutions took part, 16 pedagogical universities and 15 institutes of postgraduate pedagogical education, 2018-29, taking into account the adaptability indicators, we established that currently none of the survived Ukrainian institutions used adaptive platform. We consider the following reasons why Ukrainian institutions of pedagogical education do not use adaptive system. No localization, only English content and technical support, the potential for bugs, failures as adaptive platforms are difficult to implement, so to test them flawlessly is almost impossible. The cost, which is rather high for certain individuals, including teachers. There are currently 2 free adaptive platforms, trial versions only. The purpose of the research is to consider the concept of smart system of open science in the context of teachers' education, to evaluate the state of the art on the problem of elaboration in Ukraine and foreign educational spaces and consider the possible methods, forms, and recommendations for educators on using smart systems of open science in personalized learning implementation. Based on the analysis of research trends in education, key concepts of investigation and interpretations of the basic terms were defined. The cloud-based learning and research platform, the cloud-oriented methodological system, a smart system of open science, big data, fire data. In 2021, a planned research methodology of using cloud-based system of open science in educational institutions has been started in the Institute for Digitalisation of Educational of National Academy Science of Ukraine, devoted to the issue related to the digitalization of open science. For this purposes, the special training courses and appropriate learning methods were elaborated and implemented at different levels. The expected result was intended at expanding access to cloud services to support learning, increasing the level of organization of the educational process, in particular the research component, increasing the level of ICT competence of learners. Among the areas of smart system of open science, introduction for teachers training, there are such as to support individual and collaborative forms of learning activities in the classroom and also in the extra classroom using the services of the public cloud-based platform for educational purposes. For example, Microsoft Office 365, Microsoft Teams, G Suite for Education, FaceTime, Google Duo, Hangouts, and others. To include the cloud services of open science, in particular the services of European Open Science Cloud, into the process of teachers training and professional development in educational universities and postgraduate training. To create the smart system of open science in educational universities, including facilities and services of scientific educational information networks, cloud databases and data collections, cloud-based office software applications, specialized software training tools, as well as ERSC services. To introduce and implement specially designed and tested cloud-based methodological system into the process of educational personnel training at different levels. Conclusions. One of the main conditions for improving the quality of training of scientific personnel, increasing the level of their professional competences, wide use the innovative pedagogical technologies, expanding the sphere of research approach in teaching is the introduction of smart open science system in pedagogical and postgraduate pedagogical education. As a consequence, the introduction of open science norms in Ukraine should lead the greater exchange, contentability, reproducibility, and reliability of scientific materials and affects the learning process as a whole. The introduction of cloud platforms and services in the educational process leads the emergence and development of forms of organization of educational and research focused on joint educational activities, creating more opportunities for educational and research projects. Prospects for future research are the study of tools and services for the formation of cloud-based open science system in educational institutions, justification and development of methodological system use of cloud-based open science system in the educational process of higher pedagogical, postgraduate pedagogical educational institutions, providing guidelines for teachers training. Thank you for attention. Do you have any questions?
Thank you. And we invite everyone to take part in the discussion. Want to ask the question? Anyone? Well, while
one question. I have one question.
Want to ask you if no.
I have one question.
Please.
Please. Tell us, please, what Ukrainian or foreign institutions do you analyze in your research?
Thank you for questions. We analyze the Arizona State University, USA. As a result of training our 200 students, for respondents, we analyze we analyze studied grant, large scoring, investigated the impact of open science of research educational. We would like to draw attention to the adaptive learning platform Quantum, they is foreign, etc.
Thank you for answering.
Thank you. Anyone want to ask the question? If you know have a question, let me ask. Have you researched different system and the criteria and indicator of the section selection?
We do not show in our research criteria, but our respondents take on the questions about what platform adaptive you use. This is questions is very they not be used the criteria specified.
Okay, and which field of the teachers do you consider in your research?
We teach in our research field is mathematics, physics, chemistry, manager of educational institutions, teachers of college of vocational schools, teachers of general secondary schools, etc.
Thank you. And let me ask you one question. And what smart system would you recommend it in the first place?
We recommend and we used the USC and they specified services, cloud services, maybe Office 365, maybe Moodle, but they is not adaptive, only adaptive. But the first, the USC, European Open Science Cloud, and they services, cloud services.
Thank you for your answers. Anyone want to ask the questions to the Maya? We have no questions, then thank you for your answers. And now we invite the next author to speak. The next author is Lyudmila Gryzun.
Hello to everybody. I'm happy to greet all the participants of ICon-MaSTEd International Conference. And I'm happy also to introduce my core speakers, Lyudmila Belausova and Natalia Svetlana Litvinova. My name is Lyudmila Gryzun. I am a professor of Simon Kuzmets, Kharkiv National University of Economics. The topic of our presentation today is practice of applying a functional approach to the design of digital learning aids. The importance of the research is caused by some core factors. Among them, there is need for the digital learning aids of new generation, which is increased by the urgent needs of contemporary education. The design of nowadays digital aids should be provided on the base of the progressive approaches, which are relevant to the realization of prospective educational paradigms. Also, the process of preparing of pre-service specialists today for successful work in the contemporary world currently needs for modification on the new level. And definitely the situation with vocational training is exaggerated nowadays by the unexpected circumstances caused by the global pandemic, war situation, and urgency of development new forms of teaching and learning. Thus, the current challenges cause upgrading the model of the specialist training based on new paradigms. And one of such paradigms might be holistic educational approach. The central idea of holistic education is cohesive development of the whole personality based on the strong links between personal experience and real-life problems. Upgraded model of this specialist training based on holistic approach implements holistic approach in the complex of aspects. First of all, it should be based on concentration and generalization of educational content, on the representation of the educational content directed on the stimulating of cognitive processes, and natural merging of students' educational practices with real-life challenges that can be achieved via project-based learning and project-based activity. Essential component of such an upgraded model is a preparation students for the design of innovative learning aids based on the analysis of their didactic functions in the progress of project-driven activity. The aim of our work is to highlight practical aspects and experience of the functional approach applying to the design of contemporary digital learning aids in the progress of project-based activity of the pre-service IT specialists at their holistic vocational training. The theoretical background of work is made by holistic educational approach, which I covered above in brief, and functional approach to the design of digital learning aids. This approach is based on the deep analysis of the didactic functions of the learning aids and the ways of their realization by the learning aid. It is done to determine the functional charge of the aid structure components and the relations between the fulfillment of their certain functions. In general, the issue of classification of functions is really deep question, and it's not ambiguous one. Based on different studies, we tried to distinguish the groups of functions and accumulated them. Integrated them. For example, the first group of functions promotes study motivation of the pupils and students. The second group of functions provide efficient representation of the learning content and its successful digestion. Then the group of functions of tutorial, which process optimization in the lines of adaptation to the trainees' learning needs. And finally, these are meta functions that encourage trainees' progress and increase their general educational potential. In fact, the functional approach as a base for learning aids structure and design determines the structure of the aid, pins up the relations between its components, defines the mechanisms of these relations realizations. And in such a way, a contemporary digital learning aid is transformed into the entire tutoring environment that is able to overlay the facilities of the complex of typical learning aids. It absorbs the didactic facilities and covers and overlays them, and it becomes possible thanks to the using advanced technologies in the process of its design. This approach contributes to the shaping of the specific requirements to the learning aid in the process of their development and to the features of its design. This makes the process of the aid development practically driven, which is really essential for the students' project-oriented activity. So based on this theoretical framework, we'd like to present the experience and how this functional approach was applied to the design of digital learning aids during the project-based activity of potential IT specialists at the holistic vocational training. And now we are going to cover some practical aspects and experience on some special examples. Example number one, that is multimedia tutorial for English learning support created by the potential teachers of computer science and English together. At the initial stage, the didactic functions and structure of the multimedia tutorial were specified by the students due to the needs and problems of foreign language mastering at school. Also, they were revealed and determined basic demands to the tutorial, the financial facilities and structures. So here you can see the results of this initial stage of project-based activity. They were revealed by the students that the didactic facilities of multimedia tutorials should include high quality visualization of educational content, which will allow to implement the set of didactic functions, which you can see on the screen. The acquisition of linguistic competence also with revealing the functions, working out of various skills of speech training, the cognitive activity management, easy integration with other e-resources, strong feedback with the potential pupil, and for each of these didactic facilities, students revealed the didactic functions which belong to different groups, which I covered above. This analysis allowed to build a structure, determine the structure of the potential multimedia tutorial as a complex of related components. And you can see here that a learning activity management component is a core one, and it also has access into different other components such as multimedia interactive video library, illustration library, a bank of interactive exercises, and so on. On subsequent phases of the students' project, this multimedia tutorial was developed by the students within an Our Books environment with a great deal of HTML programming. So cloud-based multimedia tutorial, multi-English, covers the set of topics in its content, and all of the topics are focused in main categories. The students distinguished such categories such as let's focus on vocabulary, reading, grammar, listening and speaking, covering mostly all of the communicational linguistic competences. On these stages of the project, lots of HTML programming elements were developed in order to extend the natural facilities of our books environment. In particular, it was via HTML programming, it was realized integration of interactive elements from other services, which is impossible in our books in its natural version. Also, via HTML programming was done creation of the media content, text formatting was also extended, integration of the interactive video was done with the didactic support and so on. On the final stage of the students' project, the didactic features of multimedia tutorial were revealed, analyzed, tested with some conclusions. I'll cover it very briefly here. First of all, high quality visualization facility was done due to realization of library of multimedia illustrations, formation of linguistic competence due to the library of interactive video stories with didactic support. Skills training is realized via the ability to record the student's speech and special feedback from the teacher. Via the bank of interactive exercises, which include lots of exercises of different types and different levels. Arrangement of cognitive activities, including game activity, also was realized by the students in this tutorial due to a learning activity management component. Feedback component allowed to realize trainees' communication with the teacher. So at the final stage of the students' project, summarizing the analysis of the developed multimedia tutorials, students could conclude that tutorial designed on the basis of functional approach becomes really innovative. It creates for the trainee the integral cloud-based cognitive environment oriented on the activity-centered learning. Our second example we would like to share here, there is a different type of tutorial. There is the e-guide on the cryptography fundamentals created by the pre-service IT specialists, which is very important because IT specialists, they are not a potential pedagogics or potential teachers, but they also used our functional approach to creating of e-guide. Again, on the initial stage, the didactic functions and structure of the e-guide were specified due to the needs and problems of the course information security, which is a basic course for lots of vacations. Also, they were reviewed by the students and determined basic demands to the tutorial and their functional facilities and structure. And this type of e-guide has a special structure where theoretical hypertext component is centered one, and it has access into learning tasks library of static and dynamic functions, along with feedback component and technological component. At the subsequent stages of the students' project, the e-guide on cryptography was developed by the students within the MS Learning Content Development Systems, and the main topics covered in the tutorial are given on the slide. Library illustrations contains a great deal of static images and dynamic visualizations, which allowed to implement informational transformation and systematizing functions due to the great level of visualization of encrypted algorithms, the processes of work of encryption systems, and so on. The library of learning tasks, which is an ingredient of our e-guide, includes so-called teaching tasks, training tasks, and cognitive search tasks. Teaching tasks, which are ready-made programs that implement a certain encryption algorithm to run this algorithm, to analyze the operation of the algorithm, and to make conclusions by answering questions, which is encouraged by the e-guide, and which students have to follow too. Training tasks, they are similar to teaching tasks, but they are proposed to solve independently based on the theoretical content and program implementation of teaching tasks. And finally, there is cognitive search tasks, which expect applying students' knowledge at creative level. Here you can see the episodes of work upon different types of the tasks, which allows to implement the functions of consolidation and development. Also, the self-checking system as a component of the e-guide on cryptography presented in the e-guide with the help of Google Forms. The system includes a set of generalized test tasks to check the level of mastery of educational material given in the e-guide. The form is connected to the Google spreadsheet, and the answers of the respondents are automatically stored in it, which in turn allows the teacher to analyze the trainee's achievement. In such a way, the group of function is implemented. You can see it on the screen. To sum up our experience and examples, it's good to emphasize that the functional approach was applied by the students to design of the digital learning aids demonstrated its great benefits as for the quality of the aids as the results of the students' project-oriented activity. In particular, the functional approach enabled the students to specify the goals of development, to determine the aid structure, components, to control the process of aid development, etc. The result of the academic project-oriented activity had not only a learning value, but also obtained essential practical application. The elaborated digital learning aids were approved in the real educational processes at school and at university during various kinds of students' practices. On condition of such an interdisciplinary preparation and project activity, pre-service IT specialists obtained meta skills on the design of innovative digital learning aids. In the process of this kind of training, potential pre-service IT specialists of different branches obtained full understanding and capability for practical embodiment for core ideas of holistic educational approach via their personal experience of development of their learning aids. In addition, the application of the functional approach made students' project activity more practically driven and motivational. Thank you for your attention, and I'm ready to your questions.
Thank you. Who want to ask the question? Everyone can ask question in the chat. If you have no questions, let me ask. Do you consider the specific of training IT specialist in your research?
Definitely yes, because as you could understand from my presentation, different types of IT specialists took part in this project-oriented activity, and some parts of them were pre-service informatics and computer science teachers, and some of them were just IT specialists in computer science branch. For these students, it was the first stage of project-based activity was a bit different, because these students had to master a bit the peculiarities of functional approach and didactic base of creating of learning aids. That is what the main peculiarity of their work, because they usually try to create all digital aids, something like typical software. And they try to detect the functions as not from didactic side, but from the side of the user, to analyze the user's profile and so on. And that for these specialists, it was necessary to get them familiar with pedagogy, with didactic basis, and with functional approach from didactic side. That is what the peculiarity.
Thank you. And let me ask one more question. You are talking about the development of an electronic book based on cryptography. What did you mean? How did you use cryptography in your research?
Cryptography, the matter is that it was one of the aim of the project to create e-guide or electronic tutorial for basics of cryptography. So the basics of the cryptography as it was based as a content basic for this electronic guide. So we analyzed different books on cryptography. We analyzed also the content of this course, university course for different vocations training. And based on this content, we used it in order to fill in the theoretical component and to pick up necessary tasks in order to work out these theoretical basics of cryptography.
Thank you. And maybe anyone want to ask the question? I know that we invite everyone to take part in the discussion, yes, and thank you for your answers. And now we invite the next author to speak. It's Natalia Kuzmina.
Dear participants of the conference, I'm Natalia Kuzmina from the Dragomanov National Pedagogical University. Let me introduce also Petrosa Musenko National Technical University of Ukraine and Anatoly Kuzmin Taras Shevchenko National University of Kyiv about some aspects of the organization of students' individual work at pedagogical universities in the process of teaching classical optimization methods. We analyze the specificities of organizing the individual work of students who study according to the dual educational system by using new approaches in the educational process, such as elements of flipped learning and the using of the modern information technologies. The main purpose of introducing a dual educational system at a pedagogical university is to create conditions and opportunities for the most prepared and motivated students to effectively combine theoretical training at the university with the practical implementation of their knowledge at school. These are students of computer science specialties who were the participants in the pilot project of implementation of the dual system of education at our university. They learned respective disciplines according to individual plans and schedules. One of the effective ways of organizing students' individual work is a technology of flipped learning through various e-learning courses, for example, the distance learning system Moodle. The using of flipped learning technology provides an opportunity to make the transition from the teacher as the main source of knowledge to practice-oriented learning of students and their active involvement in the educational process. Unfortunately, it should be noted that the interest of modern young people in the classical theoretical study of mathematical disciplines has decreased. Most of students use, if it necessary, the internet reference resources or the most simplified methodological developments. Therefore, to provide students with the basic theoretical knowledge, it's necessary to use new approaches in the educational process with modern information technology. In particular, computer math systems are advisable to use not only while performing the practical tasks, but also during teaching the basic theoretical mathematical foundations, avoiding at the same time incorrect simplifications. Some aspects of teaching classical optimization methods in the course of mathematical programming to students of computer science specialties are presented in our article. The subject of studying this course is the basic information about the problems of mathematical programming, classical optimization methods of functions of one or many variables, The basic formulations review methods of researching and solving problems of linear, nonlinear, integer, discrete, stochastic, convex, dynamic programming, and also modern information systems and technologies that are used in researching and solving the specific applied problems of mathematical programming. To effectively organize the individual work during their studies, students should develop, implement, and protect their individual or group projects. Here is the example of tasks of the individual project during teaching the mathematical programming. Task 1. Formalize, build mathematical models, solve the ancient extreme problems such as Euclid, Tartaglia, Kepler, Steiner, Heron, Apollonius as nonlinear programming problems. Solve the selected nonlinear programming problems by Lagrange multiplier methods, then by a classical method of finding all extremums of functions of one on many variables, then by approximate gradient methods, then by using the genetic algorithm. The last task, compare and analyze the results. Further, we demonstrate some elements of performing such tasks in the environment of Maple computer math system for Kepler and Steiner ancient extreme problems as conditional and unconditional optimization problems, respectively. You can see the geometric visualization and mathematical models of Kepler and Steiner problems. Kepler problem. Fit the largest volume cylinder into a sphere of a given radius r, two-dimensional model and one-dimensional model. Steiner problem. In the triangle plane, find a point the sum of the distance from which to the triangle vertices is minimal. Its model. Numerical solution of the Kepler problem for a sphere of the given radius with using the extrema function is presented here. The answer coincides with Kepler's analytical solution of the problem with sufficient accuracy. On the next slide, Kepler problem solution by using a package optimization is shown. The results coincide with above. Further numerical solution of the Steiner problem as unconditional optimization problem by using the minimize function is presented. The Lagrange multiplier method, the main idea of which is to transform the conditional optimization problem into the unconditional optimization problem, is implemented in many optimization software packages. Further, we demonstrate the Lagrange multiplier method application on the example of solving Kepler problem and compare the results. The sensitivity report obtained by using MS Excel, according to which the Lagrange multiplier coincides with the results given above. Further, we demonstrate the solution of the above nonlinear programming optimization problems by classical methods of finding the extrema of functions of one Kepler problem and many variable Steiner problem using the necessary and sufficient conditions for the function extremum. Finally, we present a fragment of the Kepler problem solution by using a genetic algorithm. The results are acceptable in comparison with the above. Conclusions. Such methodological aspects of organizing student individual work in the process of teaching mathematical programming with the computer support contribute to the development of their creative abilities as well as mathematical and IT skills that they use in their professional activities. Thank you for attention.
Thank you. Who want to ask the questions?
So if I can, may I ask?
Please.
Thank you for your presentation. And I have a question about flipped learning. You said that you used flipped learning also in order to organize individual work of the students. Yeah, could you give an example of flipped learning activity? And do you find it really, really efficient, effective for organizing students' work?
Okay, thank you for your question.
Thank you.
We teach master students. Our students, most of all, are teachers in secondary schools. And they have individual study and they have individual lessons in university. That's why we prepared such courses, many courses for any discipline, for example, mathematical programming, which we show here. And they learn all theoretical material, the examples of the tasks at home, and we in the classroom, we only discuss about their activities and what they learn at home, what difficult, because individual learning, individual studying. That's why flipped learning, the main studying at home and at schools, and only some consultation in classrooms.
I see. You mean flipped learning in this format? Yeah. Also, no, but we also try to use, especially during pandemic time. It's very efficient. But I do it with younger students, which attend online classes, and it's quite interesting. When they obtain their tasks beforehand, they get ready, and then they share their results of their work for the group, and it's quite efficient because they become both presenters and listeners at the same time, and it really works. Okay, thank you for your answer. Thank you.
And our students are teacher at the same time.
I see. I see.
And they teachers.
Thank
you for a question.
Thank you.
Thank you. Anyone want to ask the questions? If you have no question, let me ask one more question. What a new approach to the learning process using modern IT, including the computer mathematics system, Apple, you used in your article, in your research?
And another mathematical systems? Or what do you mean?
What are the new approach you used in your research?
We used the mathematical system, and the Maple mathematical system is example of our using, but students may explore another mathematical system such as Wolfram Alpha, Mathematica, Usual, and in another systems. This no principle, but Maple mathematical system is the best for mathematics all the years, and that's why we use such approaches in our lessons.
Thank you. Anyone? Yes, Alexeyevich.
Thank you, Natalia Mykolaevna. One more question. Wolfram Alpha is a kind of free speak for math, especially for young students. How you can compare the strict notation that used in Maple for your work and attempt to say something with math using Wolfram Alpha, which approach can be more effective at the different stage teaching numerical methods.
Thank you for a question. Our students take for their best math system for principal mathematical tasks. For example, when they have to show some graphics, some geometric illustration, they take any system, and I show you maybe the best mathematical system, because optimization, algebra, any mathematical researchers can in these math systems.
Thank you. One more question. Traditionally, when we teach numerical methods, we use multi-dimensional functions. Multi is a 2 or 3 dimensional, which we can visualize. Indeed, when we use the big dimension tasks, machine learning approach, so on, we have some things about the problem of local and global optima. For example, some Coursera lectures are introduce the idea that in a very multi-dimensional 20 or more space, we don't need to discuss the problem of local optima. In any time, we must do our gradient descent, and it insists to be throwing the global optima. What you think as the professional mathematics?
We have another tasks in our course because we have only 12 hours or 12 academic hours. Do you hear me? 12 mathematic hours. That's why we'll try to show the theoretical methods, the numerical methods, the genetic methods, and for example, in one task, different methods, and compare the results. That's why your questions is very interesting, and we'll be think about it in our future researches. Thank you
for your answers. Anyone can ask the questions. Yes, and now we invite the next author to speak, Natalia Valko.
Dear colleagues, we present review of state of computer vision technologies development in the world and in Ukraine. Machine learning, natural networks, artificial intelligence are topic of interest of the last few years. The reason is increasing interest of technology and their preparation of everyday articles. Financing, insurance, anti-influence, recommendation, and forecasting, NLP. Growing interest in the IT industry is offering more quality developments in these areas. Every industry has already tools of the artificial intelligence technologies. For example, Google Smart Search, contextual advanced mobile applications such as refers, smart assistants, DSS projection tools, drone production, optimized, personalized treatment, recommendation, and etc. To analyze this situation in computer vision technologies, we analyze the number of partners on the field. In recent years, the number of cranes that significantly such computer vision gives more than 1,000 results. In the period of 2016-2019, there was a significant height in the number of developments. In the period of the 2019-2021 pandemic, health principles are important and corporation development technologies for medicine and the leader in the number of developments. Research areas of the largest corporation in computer vision: emulation, motion tracking for medical device control, user interface for medical robotic system, mapping and navigation method and system for medical device, developments in the field of detection and assessment of barriers on the road driving a car, construction of trajectories, detection of weather conditions for driving, smartphone bus content processing methods and systems, object recognition and related machine streams, objects identification, etc. Visual tracking, collaboration system and methods, dynamics, eye tracking, collaboration, graphic based control system, and etc. The popular research areas are generative artificial natural networks, image development, processing, video image overlay movements. Among the new algorithms of the generation of images by graphs, segmentation and detection problems for static images have excellent results. New research is trying to solve not only the generation problem but also generation according to give parameters. Surveillance and visual search system along the algorithm for identification and recognition of gaseous movements, algorithm for classification and categorization of data have been developed. For example, the Darwin tools automatic data labeling provides control over the annotation workflow and helps identify the data quality issues. The separate category of optical character recognition, the varieties of mechanical algorithms are used, such as statistic correction, tracking, outside area refinement, mathematical monitor, and transformation methods. Robotic processing automatization, computer vision, technical navigation system, device for tracking of guideless instruments. Such works are development of the control and medical instruments introducing and or manipulation robotic teams, device and prosthetics. Natural language processing and industrial irrelevant chatbots, the use personalized response to customize of organization, voice assessment, email that automatically sorts email, etc. Identification of such contents includes determining the content relevance. Ethic of computer vision system, data anonymization, along the topics that come to the fore is the topic of ethic artificial intelligence. In particular, in object recognition task, researchers such as present programs for recognition face and numbers of the crowd. However, there are articles that describe algorithms and technologies that protect arbitrary people from anonymized surveillance. The development of Facebook present algorithms that level the faces of each face and make it unrecognizable to detection algorithms. Google and Microsoft also enterprise the ethic of algorithm intelligence and computer vision in particular. They published the principles of construction of AI, its just types. During the pandemic, artificial intelligence technologies and machine learning algorithms received a strong impetus for their development and stopped to be hobbies, brought additional profiles to business and become the hope of inventing drugs and quality outcoming the pandemic effects. One of the largest archives of electronic publishing in scientific articles archive has more than 8,000 articles in computer vision. Picture present the number has grown significantly in recent years from a new 100 to 2,000 a year and contends to increase. In addition, the number of conferences and competitions dedicated to computer vision has been increased. The most popular computer conferences in computer vision in a list. Since 2040, a number of conferences dedicated to AI and computer vision have been held in Ukraine. There is AI Ukraine conference since 2017 to acquainted with the business application of computer developments from around the world. Present researchers in three streams: data science and machine learning, big data and data analysis, AI for business and products. The development of machine learning and computer vision in particular raises a number of issues that need to be solved in the near future. One of them is the introduction of computer vision study in curricula. Today there is a need to attract more students to study computer vision. Curriculum of neural network study exists in some universities in computer science specialty. Ability to resource such as OpenCV allows students to engage to task subject the image analysis and processing, physical recognition system, object identification, motion tracking, motion analysis, process assessment, object identification, image segmentation, and video tracking, and other. Examples are the tasks of the object movement tracking on the static background of parking place finding. The results would be related to topics as deep learning, convolution, neural networks, learning system, virtual reality, deep neural network, artificial intelligence, convolutional neural networks, the Boltzmann family, including deep belief networks, and other. There is the example of the project development by the students in a virtual environment using computer vision algorithms. The Unity 3D games engine we used to increase a virtual environment with the car. This engine was chosen as the symbol of the most capability of the car basic machines, simulating the camera objects was developed and attached to the car model. The control of a virtual vehicle was moved automatically on the line was down. To solve the problem of finding the way of the photo and attempt to create an O algorithm was made. Its advantage will be speed actually for a science as the algorithm can calculate the path of a few steps ahead. As a result, our own algorithm to find the path of the image for camera was developed. It was on the sampling principle of the whole path into parts. We consider the challenge we face in world leaders and researchers in the world of computer vision. The number of such studies in the growing and computer vision tracking methods are being developed. In here, their number is still small, but in the results show of the other develops among the first of the world rankings. Therefore, it is important to create special course to study the methods of computer vision and implement the practice teaching methods for future professionals. Great thanks for your attention.
Greetings to all conference participants.
Thank you. We invite everyone to take the part in the discussion. Who want to ask questions?
So, may I also ask a question about
Yes, please.
prospects of computer vision? It was quite interesting review. I have a question on the prospects of application of computer vision in educational sphere. Can you see some ideas as how to apply these methods to education and to improving education, maybe to making personalized learning systems, so building personalized learning models, or maybe some others? I don't know. Are there any ideas and research on this topic? Thank you.
Thank you for the question. I think the role of computer vision education is increased in last time, and we made to find a new way to find terms and any way to take the STEM to in school, in universities, and we find some interesting application which can used in school and in educational of pre-service teachers. In our work, we used work of our engineer students, and we can this work to adapt for educational of pre-service teachers.
Thank you. Thank you.
Mm-hmm.
Anyone want to ask the question? Let me ask one more question. What is the role of the computer vision now in the development of educational technologies?
The role of computer this technology is increasingly educational. Therefore, we build new programs and include these topics in our program. And we need to start teaching of these gems.
Thank you. And maybe someone want to ask the question? If you have no questions, thank you for your answers. And I want to know that everyone can ask questions in the chat or online. Oh, Sergey Alexeyevich, maybe you? No. Okay. And now we invite the next author to speak, Oksana Treshnikova.
Greetings to all conference participants. My name is Oksana Tereshchenkova. I am Associate Professor of the Department of Innovative Technologies and Technical Devices of Navigation. Title of our article is Calculation of Storm Fuel Supply of a Seagoing Vessel, Solving Professionally Oriented Tasks Using Cloud Services. The information and communicative competency today is an integral part of professional training in any sphere. Due to the fact that nowadays big amount of work is done monitored in the remote mode, The requirement is stipulated for every specialist to be able to use digital technologies professionally. For a future seafarer, it means, first of all, the ability to use modern technologies as information and data resource, and also it presupposes the ability to work with software libraries, to create databases, to perform necessary calculations by means of cloud services inclusive. This article proposes a strategy for solving an applied problem using an information modeling approach to the analysis and evolution of the technological process, namely the algorithm for calculating the required voyage and storm fuel reserves of marine vessel. Both Office spreadsheets and cloud services were used to implement the mathematical model for solving this problem. The professional qualification of shipping industry workers must comply with the International Maritime. Maritime academic graduates over a period of many years have proved to be competitive specialists. This fact enabled their employment in hiring international shipping companies. In the context of IMO requirements, information technology as a technological science and a subject form a holistic information space of knowledge aimed at solving any task related to professional competences. The main objective of course Information Technologies, which is taught during the first year of education in Maritime Academy, is the provision of the digital literacy of future shipping industry personnel. On the current slide, you can see, like example, which task type the content of academic material of the course Information Technologies includes. When teaching the course Information Technologies, the computational and graphical potential of Microsoft Excel and Google Sheets were used for computer modeling. So, the subject of the research is the newest conceptual approaches to the usage of computer-based modeling in the process of practical problem solving for the formation of professionally oriented competences. The paper objectives: the methodology development for the technological process modeling on the basis of the spreadsheet Microsoft Excel and by means of cloud services used in particular. The specific position among all cloud services belongs to the Google Workspace package. Google Workspace is a web application based on the cloud computing, which provides both teachers and students of higher education establishments with the instruments required for the effective communication and cooperation. The main advantages of Google Workspace usage for the educational purposes from the point of view of a user are minimum requirements to the hardware. Google Workspace supports all operation systems and client software programs which are usually used by students and educational establishments. The work with the documents is done via any mobile device which supports web browsing. All Google Workspace for education instruments are free of charge. Let's analyze in detail as an example one of the tasks studied during the course Information Technologies and which has multiple purposes. We need to determine the amount of fuel stores required for a period of independent sailing of a ship. To provide for the safe operation and exploitation of a ship, it is necessary to calculate correctly the stability, the buoyancy, the trimming, and other vital seagoing characteristics. When determining these parameters, it is required to take into consideration the correct ship loading and the cargo plane, which should be in all respects correct and in compliance with all the rules and requirements. Before preparing a cargo plane, it is necessary first of all to pay attention to the storage of all shipboard supplies, among which fuel is considered in the first place. The fuel stores calculations is a complex task which must take into account many factors. As you can see on the slides, these are the factors that influence the general fuel consumption on ships and factors that influence the fuel consumption rate on ships. When determining the amount of fuel supply, it is necessary to take into consideration the fuel ration en route as well as the fuel ration at anchor, in which case the consumption depends on the operating principle of loading and discharging procedures. After the calculation of the amount of fuel stores with the account for all the above-mentioned factors, it is necessary to add to the received number approximately 15 to 20% more to establish the supply needed for the case of stormy weather. In some shipping companies, there are some norms of the amount of fuel supply for the case of stormy weather established by usually they do not exceed 20% of the fuel amount calculated for a voyage. For the small power ship engines, the percentage of the fuel supply for the case of stormy weather is smaller. We can see on the next slides that in summer for all areas of the world ocean, 3 to 5%. But there are some exceptions, and in winter period the percentage of the supply for the case of stormy weather depends on the sea where a ship is operating. There are different methods of ship supplies calculations. For example, to calculate the amount of fuel needed for the voyage with the account for the amount required for the case of stormy weather, it is possible to use the formula. Taking into consideration the fact that the amount of fuel supply immediately depends on the voyage duration, it is necessary to determine the sailing time first with the account of possible delays. It is necessary to take into consideration the time of ship's berthing time in ports, which in turn depends greatly on the amount of the cargo to be loaded or discharged. In that case, the formula to be used for the amount of fuel stores calculation will look like following. The mathematical description of the bunkering procedure optimization can be represented by the following correlations. For purpose, in order to explain the CAD as a problem-solving algorithm, it was decided to create the framework for the spreadsheets which contains all necessary basic information. In this part of the research, it is proved, first of all, that the spreadsheet is a universal application which can be installed on all shipboard computers or can be used as online service. This fact allows for the creation and support of the unique database, both professional and copyrighted programs. Second of all, it has been demonstrated by the means of the example how to analyze a technical task and to optimize their further work. The use of Excel spreadsheets capabilities enables the automation of the calculation procedure, and developed efficient mathematical model takes into consideration all the impact factors that can influence the calculations. Before the suggested methodology was introduced into practical process, the authors made the teachers of professional subjects get familiarized with its content. During the process of familiarization, the teachers were suggested a questionnaire to complete with the purpose to determine the practicability of the suggested package. To prove the adequacy of the model developed, the real calculations were subject to expert appraisal. The expert commission consisted of 12 people who were asked to answer 16 questions after getting acquainted with the work of the author's computer model. The expert appraisal method is used to receive quantitative assessment of the qualitative characteristics by means of Likert scale. In this research, we have received the value of the concordance coefficient equal to 0.876. Since the coefficient of concordance varies from 0 to 1, it can be concluded that there is a high degree of agreement among the opinions of experts. Let's make conclusions. The article reveals the problem of professional training of specialists able to adapt easily and fast to the changing conditions and requirements of today in the context of information society globalization, who can use the latest achievements in the sphere of digital cloud technologies. The approbation results of the suggested methodology proved that such approach provides for the maximum involvement of cadets into the learning process. provokes the motivation to study, to analyze the problem and find appropriate solutions. That's all. Thank you for your attention. Greetings to all.
Thank you. Who want to ask the question?
Okay. Thanks for the interesting report. Please specify how exactly the course information technology was changed after the analysis of the European references framework for key competencies for lifelong learning. Thank you. Repeat.
Anna, where are you?
Okay, I sent the question in chat.
Okay, we don't see the Oksana, and while after connected, we invite the next author to speak, Daria Yatsenyuk.
Hello, my name is Daria Yatsenyuk, and I am one of the authors of the article entitled Study of Ergonomic Criteria for Evaluating the Software User Interface. This article summarized research on the development and evaluating of a set of software usability measurements. Today they are called ergonomic criteria. We summarize the research work carried out on the development and evaluating of a set of software usability measurements. The paper contains a description of each such criterion. All of them together provide a quality user interface. We also highlighted the significant advantages of a well-designed and well-thought-out interface. We discussed ergonomic problems of software development. As a result, some characteristics of the software are identified. They reduce the ergonomics of the user interface. The paper also discussed ergonomic issues and the things developers need to get rid of to make the apps enjoyable. In the article, we give some examples of user interfaces. They are accompanied by an explanation of the problems and solutions to their shortcomings. The technical devices allow you to expand or supplement natural capabilities such as complex computing, transmitting and receiving information, improving accuracy, moving in space, making decisions, and more. The aim of this work is to identify the main set of measurements of ease of use commonly known as ergonomic criteria, based on a review of already written research papers. Because the user considers the interface as a key factor in the functionality of the programs, a poorly designed interface severely limits the functionality of the system as a whole. Companies that don't seek to develop ergonomic UI for their products and get all the benefits provided by modern technology weaken their competitive position. Software designed with practically in mind is ergonomic and works exactly as users expect. As a result, users focus on their own task rather than the specifics of interacting with the software. Ergonomic software products are easier to learn, they are more effective, they also minimize the number of human errors and increase their satisfaction. Their effective user interface is a result of the developer's understanding of the need to pay attention not only to the data, but to the user, his tasks and activities. Here are some of the most significant benefits of a good user interface. There are reduction of losses of productivity of users at system implementation, faster restoration the lost productivity, reducing the number of human errors, improving the morale of users, reducing the cost of system support, and also reduction of cost for UI redesign. Each hardware or software product is a set of different functions. Therefore, it is necessary to have standards for evaluating the technology or products to the user interface. The success of solving the problem in software development depends on how functional, clear, and user-friendly the interface is. Taking into account the needs and expectations of users from the design of the interface, we can identify certain recommendations that should be followed and based on them edit the user interface. There are displayed the real world in the user interface, standards and consistency, efficiency and flexibility, recognition. Other tips are documentation and reference, error prevention, freedom of action of the user, system status, and minimalism. The point of this tip is the display should be limited to the necessary components for current tasks while providing clear, visible, and unambiguous means of navigating to other content. Based on these recommendations, the quality UI can be based on the number of criteria. We summarize the list of these criteria and present the following characteristics of software quality assessments are in table. In the table, all 16 criteria are divided into 5 general groups: functionality, reliability, usability, efficiency, portability, which give an understanding of what this or that characteristic refers to. As experience shows, many interfaces are unsatisfactory. This is because they are too narrow profile and require a fixed combination of user skills. A good interface should serve different users. From ergonomic principles, it is possible to understand why modern software cannot be used productively enough in the context of various and instructed tasks. Considering the typical modern software products, we have identified some shortcomings, such as no integration, loss of context, mysteriousness, Swiss Army knife syndrome. For example, the essence of the last disadvantage is that created huge duplication of functionality and increased inconsistency of exhausted version of much more general functions. The existence of such shortcomings imposes a large cognitive load on the user. This distracts him from the real task that needs to be done. As a result, numerous user errors become inevitable. Good UI design makes user interaction with the application or site simple, intuitive, efficient, and smooth. A bad user interface can be annoying or directly prevent users from continuing to work. I will show you just one example of disadvantages in the ergonomics of user interfaces that are given in the article, which may seem comical or downright annoying, but they are still found in UI design. The shortcoming is use of intuitive notation. Changing the language is the first thing users want to do if they open a site of software they can't read. It also makes sense to make this option as simple and optimal as possible to choose before performing any other actions such as login, registration, password change. The most successful is the idea of using intuitive notation. Let's move on to the conclusions. The problem of designing user interfaces is currently relevant. Therefore, to facilitate the work with the software product, developers need to think about and create an ergonomic user interface that would accordingly perform all the tasks assigned to it. Given the user needs, expectations, and expectations of the interface design, the paper identifies strong recommendations that should be considered and included in the editing of the user interface. We contain the characteristics of software quality assessment, namely summarize the criteria of ergonomics of the user interface based on a review of already written scientific papers. Ergonomic criteria should take into account possible errors of users. Therefore, ergonomic applications should be interactive, intuitive, interruptible, indulgent to mistakes. For a practical picture of the problems of the non-ergonomic user interface, the work contains illustrated examples of shortcomings that are still uncorrected by users and significantly affect usability. This seemingly understandable problem with default interface language mismatch is easily eliminated by replacing words with intuitive notations that successfully implement the basic functions of the user interface. Thank you for attention.
Thank you. And who wants to ask the question to this author? If we have no question, let me ask, what are the ergonomic software development issues that you are considering?
Good day. Let me to answer for this question. First of all, I would like to thank the conference chairs, Sergey Alexeyevich, Tatiana Anatolievna, Andrei Nikolaevich, and others. They have done great work, especially in this difficult time for Ukraine. So I would like to thank them for their professionalism, scientific activity, and patriotism. Consider questions of Tatiana Anatolievna. We have analyzed some criteria of ergonomic user interface, such as functionality, reliability, usability, efficiency, and portability. So these criteria may be can do software interface more flexibility and understandable for users and decrease their mistakes.
Thank you. And we have a question in the chat, how to identify if this criteria we are followed or not in your design.
Thank you for your question. We propose to identify if these criteria were followed in the user interface, thanks to teaching students to analyze some software or cloud services and make conclusion if one or other software is required to criteria such as functionality, reliability, usability, portability, and others.
Yeah, thank you. Thank you for your answer. It was my question. But are there any metrics? How to detect it? How to measure? At least for one of the criteria, because there are a lot of them, but how to use now these criteria? How to use them in practice? It's very important, definitely.
Yeah. Thank you. We agree with you. The measurement of evolution of user interface is very important. Unfortunately, in this study, we don't research the measurement problem, but I hope I and our colleagues will try to do this in future in the next our research. Thank you.
Thank you.
Thank you. Anyone want to ask the question? If you know questions, thank you for your answers. And now we invite the next author to the speak, Tatiana Nikitschuk.
Mathematical model of the base unit of the biotechnical system is a type of edge devices. The rapid development of computer biometrics over the past 2 or 3 decades is largely due to the development and widespread introduction into clinical practice of new methods of studying the human body health, including pulse methods. However, none of them meets all the requirements for models of the pulse signal in terms of rapid and pulse diagnostics. The development of such a model will allow to effectively apply modern developments in digital signal processing to the pulse wave and increase its diagnostic value. Qualitative model of pulse signal can be entrusted to the development of the base unit of the biotechnical system as a type of edge devices. Presented on the slide, another group of authors describe how edge computing is being used in the healthcare system. Vital health indicators can be monitored using edge devices such as a smartphone and sensors separately or together. Presented on the slide, the eLifeCare platform uses AI on the edge level. Scientists say that the platform acts as an alert system using early warning indicators. Another group of researchers considers the architecture of fog-based applications. They note that such an architecture consists of 3 layers: thin layer, fog layer, and cloud layer. In particular, the thin layer level includes end-user edge devices. Those are Arduino motorboards, IoT devices, sensors, body data collection tools, e.g. blood pressure, heart rate, glucose, and so on. The authors of suggest architecture for edge devices for diagnostic of students' physical condition. The biotechnical system can then be built based on their research. Therefore, the aim of this article is to develop a mathematical model of pulse wave, which will correspond to the real pulse signals for certain types of pulsations in the circulatory system, contain mathematical relationships between basic parameters of pulsograms, and will be the basis of biotechnical system to improve rapid diagnostics of cardiovascular system. The slide shows the algorithm for conducting research and automatic inference about the state of a physiological object using model data. The model analysis procedure gives an idea of the effectiveness and feasibility of applying appropriate software and algorithms to the real signal. A fragment of the model is graphically shown on the slide. On the screen shows the mathematical equation for the pulse signal of even pulse and uneven pulse, model signal of even pulse and uneven pulse. On the slide presented the mathematical equation for the pulse signal of high pulse and low pulse, model signal of high pulse and low pulse. On the next slide, you can see the mathematical equation for the pulse signal of fast and slow, model signal of fast pulse and slow. The obtained mathematical equation of signals for these types of pulse are presented in the phase plane. The numerical indicators of phase portraits of pulsograms are investigated in order to determine the criteria for rapid diagnosis. Algorithm for forming a phase portrait of a model pulse signal presented on the slide. The slide shows the phase portrait of even, uneven, high, low, fast, slow pulse. To quantify the trajectories in the phase plane, in the following indicators are considered: area of the phase portrait S, degree of chaos Sh, fractal dimension D. The results of calculation shown in tables which are on the slide. On the screen presented the algorithm for analysis of pulsograms with automated output. The future biotechnical system that will be developed on the basis of this model of pulsograms will be a type of edge devices. This system will promote carrying out express organism diagnostics on pulse signals and also will transfer results to the server of the remote diagnostic center. Thanks for your attention.
Thank you. Who wants to ask the questions?
Can I ask a question?
Yes, please.
Is the mathematical model of the pulse signal of the biotechnical system verified by diagnostic data?
Thank you, Tatiana. Tatiana, we are not hear you. Не чути, not hear. Let's me answer the question. I also author of this article. Yes, of course, this is reflected in previous work of our authors. Who can ask the question?
May I ask a questions? Can these three parameters of face portraits be supplemented by others characteristics?
Of course, for full-fledged rapid diagnostic with the help of the proposed biotechnical system will be supplemented characteristics of face portraits of pulse signals.
Thank you. I have second questions.
Yes, please.
Where can the prognosis biological system be used to the biotechnical system as a type of edge devices?
Thank you. For example, the system can be used to quickly assess the condition of students in the classrooms of educational institutions in order to identify the primary season of COVID. This is what the authors of the project at the university are working on. Thank you.
Thank you.
And Tatiana Nikichuk in chat writes that he has a technical problems. That's why if any questions are no, we are now invite the next author to speak, Vitaly Bazurin.
Good day. The topic of our study is interdisciplinary problems of mathematical content as a means of teaching programming to secondary school pupils. The authors are Bazurin, Chashishnikova, Karpenko, Pursky, and Palchuk. The relevance of the study is due to the following factors. The need of the labor market for IT professionals and higher education institutions for students who have programming skills, distance learning of students during quarantine, insufficient level of motivation of students to study programming. In our study, we relied on the research of the following scientists: Lo, Li, Yu, Shevchuk, Krivonos, and others. The aim of the research is to develop a classification of interdisciplinary problems with mathematical content and determine the impact of these problems on the formation of pupils' ability to develop algorithms and write them in the programming language. The research questions are: First, how much does the mathematical content of programming problems affect the level of formation of the ability to solve programming? Second, how different is the dynamics of the development of the ability to solve programming problems for pupils who use and do not use practice-oriented programming problems? These questions are important because they answer the questions of the effectiveness of practice-oriented interdisciplinary problems in the progress of learning of programming basics in secondary education. The main ways to solve these problems are to develop a system of practice-oriented problems and test their effectiveness through pedagogical experiment. Independent variables are the main stage of the research. The content of this task is traditional, and at the end of the stage, the pupil's ability to solve programming problems was diagnosed. The selection of pupils of control and experimental groups was carried out. Control and experimental groups were compared according to criterion here square. And the second stage, in experimental group lessons, were held with the use of practice-oriented programming problems 5 months. And the third stage, the diagnostics of the level of formation of skills to solve programming problems were carried out. Types of practice-oriented programming problems: interdisciplinary, professionally oriented, and socially oriented. The dependent variable is the level of pupils' ability to solve programming problems. We have improved the classification of interdisciplinary problems in programming by level of complexity. Please see on this slide. First, information and prescription interdisciplinary problems, learning material in mathematics and or programming as a basics or solving a programming is used. The second, reproductive interdisciplinary problems, problems to build semantic associations between the learned material in mathematics and programming. Third, research learned material problems that do not have a clear statement in the process of their solving. Pupils must determine either their condition or statement. Fourth, problematic learned material that are aimed at understanding hidden connection and relationships. The research were conducted of 3 stages: ascertaining stage, formative stage, and control stage. The results of ascertaining stage are shown on the slide. The results of control stage are shown on this slide. The second research question was how different is the dynamics of the development of ability to solve programming problems for people who are used and who do not use practice-oriented programming problems. To answer these questions, the result of ascertaining first stage and control third stage of the study were analyzed in detail and compared. The results were summarized in diagram on the slide. Conclusions. Motivation has a positive effect on the learning outcomes of high school programming. One of the ways to increase students' motivation to study programming is practice-oriented content of programming tasks. Practical-oriented tasks are the basis of programming for high school students should be a holistic system and be used in the process of studying all topics of the section of fundamentals of programming of the school course of programming science, computer science. As a result of the application of the system of practice-oriented problems on the basics of programming, students formed a higher level than students who solved programs for textbooks. As a result of the application of the system of practice-oriented tasks, a positive dynamics of growth of the level of ability to solve programming problems were relieved. Thanks for attention. Goodbye.
Thank you. Who wants to ask the question to Vitaly? Please, Natalia.
Thank you. I have two questions. What classes of secondary school do you mean in your research? And name some examples of mathematical content in your research. Thank you.
Our research has done in 7th and 8th classes. Some of the one of tasks was to develop the algorithm of resolution the equation to the sum squares of Fermat's field, as example. Other tasks were to research the algorithm of moving the total object in Python using some data structures as a list, as array, and some algorithmic construction as a cycle, as a cycle, and the such type of such data type as file.
Okay. Then thank you for answer.
Thank you. Anyone want to ask? Yes, we have a question in the chat. Kindly explain how you were able to categorize the interdisciplinary problems into 4 types mentioned in the presentation.
I explained main categories of interdisciplinary problems for the level of difficulty. The classification interdisciplinary problem is for level of difficulty.
Thank you. And I have one question to you. Can a programming task not be practice-oriented? Yes, if yes, give an example.
Yes, The program task can be not practice-oriented, because the practice-oriented approach is one of the approaches which used in learning computer science in secondary school education. Other tasks which are not practice-oriented can be to develop the algorithm as example from the textbook.
Thank you. And who can ask the question? Anyone? If you no question, thank you for your answer. And now we invite the next author to speak on the report.
Dear conference participants, the travel and salesman problem asks the following questions. Given a list of cities and the distance between each pair of cities, what is the shortest possible route what visit each city exactly once and returns to the origin city? It is an NP-hard problem in combinatorial optimization, important in theoretical computer science and operation research. The travel and salesman problem occupies a special place in combinatorial optimization and operation research. Historically, it was one of the tasks what gave impetus to the development of these areas. The simplicity of formulation, finiteness of the set of admissible solutions, clarity, and at the same time colossal cost for a complete search still push mathematicians to develop new numerical methods. All new ideas are first tested on this task. The most important generalization of the travel and salesman problem for transport and logistics what several vehicles with limited capacity must serve customs by visiting them in the specified time windows. The ideas of the local search were developed in meta-heuristic in general schemes for constructing algorithms what can be applied to almost any discrete optimization problem. These are general iterative processes what use randomization and the elements of self-learning, search intensification and diversification, adaptive control mechanism, constructive heuristic and local search methods. Meta-heuristic include genetic algorithm, evolutionary computation, taboo search, simulated annealing, greedy randomized adaptive search procedure, ant colony optimization, and others. Meta-heuristic are divided into trajectory methods, where each iteration has one valid solution and the transition to the next, and methods what work with a family population of solutions. The first group includes taboo search, simulated annealing, and other. Trajectory methods live in the search space a trajectory, a sequence of solutions where each solution is adjacent to the previous one, concerning some neighborhood. The second group of methods includes genetic algorithms, evolutionary computation, and ant colony optimization. At each iteration of these methods, a new solution of the problem is built, which is based not on one but several solutions of the population. Attempts to spy out of the methods of solving difficult combinatorial problems in nature are finding a new incarnation in numerical methods. Artificial intelligence research Marco Dorigo described in 1993 a method of heuristically generating good solutions to the TSP using a simulation of an ant colony called ant colony system. It models behavior observed in rural ants to find short path between food sources and their nest, and emergent behavior resulting from each ant's preference to follow trail pheromones deposited by other ants. Ant colony system sent out a large number of virtual ant agents to explore many possible routes on the map. Each ant probabilistically chooses the next city to visit based on a heuristic combining to the distance to the city and the amount of virtual pheromone deposited in the edge to the city. The ants explore depositing pheromone on each edge that they cross until they have all completed a tour. At this point, the ant which completed the shortest tour deposits virtual pheromone along its complete tour route. The amount of pheromone deposited is inversely proportional to the tour length. The shorter the tour, the more it deposits. In our time, the traveling salesman problem, TSP 3D variation, has gained new application. For example, in the process of 3D printing, there is a need to minimize the transitions of the printhead from the endpoint of the path to the starting point, which reduce the deteriorating print quality. The problem of unmet aerial vehicle trajectory optimization is also related to the two existing common classic tasks, the salesman and the transport problem. The problem of three-dimensional UAV path planning areas when it is necessary to plan traffic in mountain conditions or a multi-story urban development. With the increasing complexity in indoor living environments, there is a growing need to optimize indoor navigation. Thus, we can see the widespread use of ant colony optimization in various fields, which indicates its effectiveness and versatility. As mentioned above, if the vertices of the graph are points of the plane with coordinates x and y, and when in the main matrix traveling Salesman's problem, the elements of the matrix are determined by the formula of the Euclidean metric. For the Salesman's spatial problem, the distance matrix will be determined by the formula on the slide. We propose the use of the ant colony optimization algorithm to solve the spatial problem of Salesman 3D variation of TSP. The ant colony method can be applied to any combinatorial problem that can be consistent with the following requirement: appropriate representation of the problem. The solution space should be represented as a graph with a set of vertices and edge between the vertices. A correspondence must be established between the solution of the combinatorial problem and the root in the graph. It is necessary to develop rules methods on the slide. An important rule in ant algorithm is played by the probably proportional rule, which determines the probability of transition of the k and from city I to city j on the t iteration. The choice of the city is based on the principle of the roulette wheel. Each city has its sector with an area that is proportional to the probability. There are three variants of the ant system algorithm which differ in the method of calculation delta tau sub IGKT. In the first variant of the ant cycle algorithm, after the completion of the route, each ant k deposits the amount of the pheromone on the rib. To study the entire solution space, it is necessary to ensure the evaporation of the pheromone, a reduction in the amount of the pheromone that was deposited in the previous iteration. Let us denote the evaporation coefficient of the pheromone by p element 0, 1. The pheromone, then the pheromone update rule will take shape, shown in the slide. You can see the flow chart of uncolony optimization algorithm on the slide. The program code is implemented in MATLAB. During computational experiments, various network topologies were randomly generated, and the number of iterations at which the optimal cycle was achieved was recorded. After the development of the end-colony algorithm to solve the spatial traveling salesman problem, computational experiments were conducted to compare the computing resource needed to solve the 2D and 3D traveling salesman problem. The number of vertices of the graph varied in the experiments. During random experiments, different network topologies were generated, and the number of iterations at which the optimal cycle was achieved was recorded. Table shows the dependence of the time to find the optimal route on the example to randomly generated test graphs with the number of iterations, 500. The execution time of the code for the TSP3D task is almost the same as the execution time of TSP2D on the slide, showing the same proportional dependence of groove after reaching the number of vertices, 100. Visualization of the best rounds was carried out using the function plot and plot3. It is worth noting that what visualization consumed most of the computing resources. Analysis by profiler showed that 71.4% used graphing function for 2D and 73.1% for 3D task on average. The results showed that the execution of the code for the TSP3D task is almost no different from the execution time of TSP2D. The results can be used for special tasks on the Salesman TSP3D variation, which arise in the process of 3D printing, planning, UAV trajectories in mounting condition on multi-story urban development, road planning in multi-story buildings. Thank you for your attention.
Thank you for your article and your who want to ask questions?
Thank you. I have questions. Say please, how effective is the end colony algorithm for solving salesman problems compared to other Mecha heuristics?
Thank you for your questions. In our work, we have not made comparisons, but in the theoretical works, which are listed in the literature to the article, you can see comparisons of some meta-heuristic algorithms. In general, everything depends on the specific task of optimization. The genetic algorithm and the ant colony algorithm are among the most effective. Another direction is being developed to create hybrid algorithms that combine several ordinary two meta-heuristics.
Thank you.
Thank you. Who want to ask the question?
Can I ask a question? I have a question.
Yes, please.
In your program, the coordinates of vertex are set randomly. Is it possible to set specific vertex coordinates?
Thank you. Yes, specific vertex coordinates can be set for all three vectors. The coordinates x, or y, or z are stored in one vector.
Thank you. And we have a question in the chat. How can you effectively test the effectiveness of the developed algorithm for use in unmade real vehicles? Thank you.
The best option, in our opinion, would be to use the unmanned aerial vehicle toolbox MATLAB. For this of simulation and hardware in the loop testing of autonomous fly algorithms and fly controllers, you can generate and simulate unmanned aerial vehicles scenarios.
Thank you. Anyone can want to ask the questions? If you know a question, thank you for your answers. And now we invite the next author to speak, Irina Ludwig.
Dear colleagues, we would like to present to your attention a scientific research on the topic project-oriented approach to the study of robotics according to the concept of STEM education. The intensive development of robotics and the use of self-regulated production systems inevitably leads to the changes in the labor market and the emergence of new professions and requirements for that. Robotics production requires specialists who can carry out its development, research, maintenance, prepare, control, design, and commissioning. This leads to an increase of requirements for modern specialists capable of innovation and the solution of non-standard professional tasks based on the development of research competence. The trends in the development of IT technologies lead to the changes in the education system and its methodologies, in particular the introduction of STEM education. Despite the widespread coverage of the problem of introducing STEM education, the issue of developing a methodology for studying technology for creating robotic system remains relevant. A feature of the educational approaches for study of robotics is the need to conduct in the various fields of knowledge, material science, electrical engineering, microprocessor technology, programming, production technology, Internet of Things technologies, and others. However, training standards and materials on the market are either too expensive or too limited in functionality, training materials or techniques. On the other hand, working with a ready-made robotic complex does not allow to master the technology of development of robotic systems. In the study of the finished complex, the modernization process is ignored. Therefore, one of the ways to teach robotics is to use a project-oriented approach and that provides solutions to these problems with a greater efficiency. The use of project-oriented approach in the study of robotics allows to fully implement the main provisions presented in the concept of the developments of STEM education. In our proposed method of using a project-oriented approach in the study of robotics, at the initial stage, a problem is selected and a subgroup of students are formed, who will solve the task. The task is selected from a wide range of practical problems. For example, the development of a robotic arm or a running gear of work or smart home and smart city elements. Students in the process of studying technologies for creating robotic systems independently develop and produce a training stand in accordance with the chosen option for a practical task. Using the developed training stand, students have the opportunity to explore its properties and ways of modernization. The theoretical material is explained on the basis of the implementations of the stage of practical development. The study presents a methodology for teaching robotics using a project-oriented approach. On the example of the task of developing a robotic platform, at the initial stage, the teacher invites students to explore the existing types of selected solutions to the problem, their strengths and weaknesses. For example, the development of a running gear is chosen, which will have mechanisms for turning each individual wheel by 90 degrees and the ability to control the speed and direction of rotation of each wheel. In the process of implementing a project-oriented approach, an important point is to hold a discussion among the students, where they should discuss problematic issues as much as possible. For example, in solving our applied problems, such fields, questions will be following. Is it necessary to choose which element base to use? What materials for the body to choose? What types of wheel is better to choose in this case? What problems may arise? What characteristics are planned to be included in the design? How will the wheels turn? At the next stage, students learn the basic functions of working with the CAD system to develop drawings of details of the design of the robot. To do this, they are provided with sufficient instruction to be able to make a drawing of the part. Such brief instruction does not allow you to fully master all the functionality of the software project. On the other hand, students are provided with additional educational material in the form of video tutorials, which will allow them to fully master this project on their own. Preference is given to pre-CAD systems and systems that allow you to work on a project in a team, such as After Fusion 360. In this case, each student develops his own role of several nodes, such as servo mounts, batteries, solar panels, motherboards, or sensors. The developed drawings are exported in the STL format, which is their subsequent preparation for printed on a 3D printer. This allows to consolidate the knowledge gained in the process of studying design technologies using CAD system and visualize the process of manufacturing the body and development and design of relevant design documentation. The next stage in the implementation of the project-oriented method is the development of structural electrical circuit diagram with its maximum required functionality. As in the case development case, first there is a discussion of conceptual scheme and the nodes that should be included in it. The component-based power supply, microcontroller, sensors are selected and their characteristics are discussed. At this stage, the theoretical material is consolidated to understand the principles of connecting the selecting microcontrollers, their settings for operation, and port assignment. To test the algorithms of these systems, students are offered to develop a simulation circuit diagram in Tinkercad. This allows you to implement the basic elements of the work and work out their interaction. This approach allows them to visualize the work of key components of the system, their relationships, and prepare students to work with the physical model. This stage also offers an explanation of the theoretical material related to the operation of controllers, pulse width modulation drivers, and servo structure. The student is invited to consider the key components of the system, their physical and software principles of operation, possible design options. At the final stage, the electrical and physical models are combined in the single stand. Motors, servos are connected. They are calibrated and the functionality of the software algorithms is implemented. This allows you to consolidate and develop skills and abilities acquired at this stage of simulation, as well as physically visualize the work of the system, its movement, and reaction to the environment. The developed design and algorithms are further studied by the students in the real circumstances. The shortcomings of designs and algorithms are sought and eliminated, their interrelations are investigated. Students are invited to study their implemented projects, for example, on the subject of motor overload, structural rigidity, cross-country ability, reaction speed. After the completion of this stage, the final conclusions are formulated, in which the key role is played by the result achieved by the students and the ways of modernization proposed by them. Since the goals and conclusions of the study are formed together with the students, this allows students to increase their competence in using the methodology of the scientific approach, from setting tasks to analyzing their results and reliability. Thus, the use of a project-oriented approach in the process of studying robotics ensures effective research work of the students, not limited to standard education stands, educational materials, and software. The use of self-developed educational stands allows to systematize information about the object of research conducted on the specific practical tasks and to strengthen the cognitive activity of the student. This approach allows you to significantly raise the self-esteem of the students and increase their motivation to learn. Working on solving problem-oriented complex tasks allows us to consider the task as a collective one, which will create the necessary prerequisites for professional activity, since in real life most types of work takes place in a team. Also, this approach allows the student to find exactly the niche in the project that appeals to them the most. Programming, development, structural detail, or the creation of electrical circuit diagrams. Prospects for future research are to improve the methods of teaching robotics based on a project-oriented approach using the potential of interdisciplinary interaction. Thank you for your attention.
Thank you. Who want to ask the questions?
Can I ask a question?
Please.
Your research is very interesting. It requires a lot of practice work. How do you solve the problem of studying robotics practice in distance learning? What tools, programs do you use? How do you organize your work?
Дякую за запитання. Я з вашого дозволу українською, з поваги до англійської. І все-таки це дійсно є проблемою в нас навчання в дистанційній формі, саме навчання до робототехніки, особливо що стосується виготовлення вже самих деталей, компонування моделей і так далі. Проте все програмне забезпечення, саме програмування, створення алгоритмів, створення програм, використовуються звичайні програмні засоби. І що можна сказати? Так само розробляти схеми можна за допомогою Tinkercad, якщо електричні схеми, і Autodesk Fusion ми використовуємо для того, щоб мати можливість працювати групову роботу, організувати в дистанційному форматі, вже створюючи графічні проекти схем. І знову ж таки, а що стосується, наприклад, вже роздрукувати, підготувати програму для кури можна, але вже надзвичайно діти не мають можливості зараз працювати, бачити, як виготовляється деталі саме в такому форматі очному. Проте десь якесь відео представити. Дійсно, це дуже проблема викладання робототехніки, всіх її етапів саме в дистанційному форматі. Дякую за запитання.
Thank you, but we ask you to try and answer in English because we have participants from Philippines. And I have one question to you. At what age should you study robotics, and are the future of study of different ages?
Вікова категорія навчання.
Yes.
Англійською важко. Зараз
So I can add, so the robotics is, sorry,
my helper.
So the robotics is very important in today's world. So basically we need to start to introduce young students and as soon as possible, because nowadays technologies is far from the point where it was like 5 or 10 years ago. So it would be advisable to start at least some algorithmic skills learning in the later ages of school. So basically in the if we take Ukrainian school, it's year 10, 11, but the more robust and the more throughout work about algorithms and microservices and other types of systems, we need to start to introduce to them at first couple of years of the university. So in the process of learning, they will be able to communicate and at productive level.
Thank you. Anyone can ask the questions. Who want to ask the questions? If we know questions, thank you for your answers. And now we invite the next author to speak, Oksana Klitschko.
Dear colleagues, dear conference organizers, thank you for the opportunity to present a report. Dear colleagues, we bring to attention report on the topic data mining in the healthcare system, based on the machine learning model developed in the Microsoft Azure Machine Learning Studio. The authors of the study are Oksana Klitschko, Роман Семенович, Виктор Михайлович Нагаев, Людмила Юрьевна Дударова, and Tatiana Petrovna Suzak. This report presents data mining, which is based on the regression analysis and machine learning. We developed and applied machine learning model, which includes the regression modules, Bayesian linear, artificial neural network, decision tree, decision forest, and linear regressions. In the process of applying this machine learning model using the mentioned algorithms, the regression models were constructed and their comparative analysis was performed. The results were analyzed. In today's world, healthcare costs are rising rapidly, primarily due to epidemic problem caused by coronavirus disease, COVID-19. Demand for quality healthcare, aging population, increasing number of people suffering from chronic diseases with long-term disease, etc. Please look at the scheme. The benchmarks of this system are the quality of medical services and their costs, which is important for the patient, not their volume. The components that are the basis for the transformation of the healthcare system are computer science, payments, benchmarking of research and tools, logistics of medical services. The results of the measurement are used to adapt health services for the populations for the mass of the patient care. Methods that improve the quality of the health services, reducing their cost, rather than increasing the amount of care. The aim of the study is to data mining of the healthcare system based on the model machine learning developed Microsoft Azure Machine Learning Studio. This includes modules Bayesian linear regression, neural network regression, boosted decision tree regression, and decision forest regression. We developed the regression modules using Microsoft Azure Machine Learning. In this study, we use data from the medical cost personal data sets, which are publicly available on the Kaggle platform. Please look table number 1. The dataset is presented in CSV format. It consists of 7 columns, 1338 rows. Data were tested for multilinearity. It is established that multilinearity is absent. The dataset contains the fields described in table 2. We conduct the study of the impact on charges. Is individual medical expenses incurred under health insurance? Predictors. Age is age of the main beneficiary. Sex of the insurance contract. BMI is body mass index. Children is number of children on health insurance, number of dependent networking region is a residential area of residence in USA. As a target, we determine the charges y. As a regressors, we choose x1 age, x2 set, x3 BMI, x4 children, x5 smoker, x6 region. The scheme of the machine learning model based on the regression construction algorithm is presented in figures. Let's describe the model presented in figures. The dataset model, you need to load the data for the further process. The edit metadata block allows you to edit metadata by selecting columns from the dataset. The split data model divides the rows of the dataset using the setting into two different sets for training and model testing. Modules Bayesian linear regression, neural network regression, boosted decision tree regression, linear regression, decision forest regression, provides the creation of regression modules using the above algorithms. Training of the regression modules is implemented using the training model block on the training dataset. The developed regression modules are tested using the school model block on the test part of the data. The evaluate model evaluates the developed regression modules using standard indicators: mean absolute error, mean squared error, relative absolute error, squared negative error, coefficient of determination. The execute R script unit is responsible for the executing the R script of machine learning experiment in order to extract any performance indicators of the model. Using the add rows block allows you to add a set of rows from the input dataset to the end another dataset. It was used by use in order to obtain comparative statistics of performance indicators of the developed regression models and to provide convenient data analysis. Let's analyze the obtained results of construction of regression models on the basis of comparative statistics. According to the average absolute error, the close to the actual result data prediction was built using the algorithm's decision forest regression. 2628.5 and boosted decision tree regression 3074.87. The worst result for this indicator 8608.14 was obtained using the neural network regression algorithms. High average absolute error at about the same level were obtained as a result of the construction of linear regression 4035 and Bayesian linear regression 4033.11. The obtained mean square error values also indicate the superiority of the decision forest regression. 4834, this decision tree regression 2688.5 alphas. As previously estimated, the values of linear regression 5875.64, Bayesian linear regression 5870.81, are higher than the experimental RMS values of the decision forest regression and this decision tree regression algorithms, and are approximately at the same level. The worst value is the result of the neural network regression 11,604.3 among the data estimate of the RMSE indicator. used the decision tree regression, 82.5%. Models obtained using linear regression, Bayesian linear regression are also adequate. As their coefficient determination is 74.75% and 75.8%, respectively. The value of the coefficient of determination, approximately 0.002, test a model built on the algorithm neural network regression indicates that the model is inadequate. The model that is closest to the actual data, the machine learning model, built on the algorithm decision force regression. Slightly lower value were obtained in the process of building regression models using the linear regression and Bayesian linear regression algorithms. The model built using the neural network regression algorithms is inadequate and unusable. This result indicates that the application of this algorithm requires additional setting, careful primary preparation of data sets. The main goal of building an integrated information digital healthcare system focused on people is to support the fundamental model of patient care and innovative value-oriented model of healthcare. Thus, as a result of the analysis of data on the basis of methods of mathematical statistics and machine learning, the following is done. A model of machine learning system of development, which includes the regression analysis model based on Bayesian linear regression, typical neural network, decision tree, decision forest, and linear regression. The model built on the algorithm decision forest regression is determined to the most suitable for use. Coefficient of determination model testing equals 83.51%. The presented methods can serve as a basis for the strategic development of new areas of medical data processing and decision making in this area. The obtained result will determine some areas of future research in the application of data mining method in the healthcare system, namely the use of machine learning system of clustering, classification, detection, anomalies, and dear colleagues, the report is out. Thank you for your attention.
Thank you for your report. Who want to ask the questions? If we have no question, let me ask one more question. What methods of mathematical statistics and machine learning are your research based on?
Thank you very much for your question. And we developed model. We used the method regression and comparative regression, decision tree, decision forest, and beta is this experiment looked and beta is the decision forest regression is beta, but I think maybe is neural network we looked inadequate in this model, but I think this need prepare coefficient and maybe another step in research we used this method.
Thank you. Maybe anyone want to ask the question? Thank you for your answer. We truly thank everyone for participating in this conference and our workshop. We invite you to participate in our next conference and workshops. And now we ask everyone to turn on the cameras for group photography. Yes. Please turn on the camera. Please, who can turn on the camera? Tatiana Nikitchuk, Maria Shyshkina. Thank you for your participant in our conference. And now we have a break. Yes, and at 14 o'clock, the next session will be continued at this link too. Thank you for all of us.
Thank you. See you later. Bye.
Goodbye.
Goodbye. Thank you. Have a nice